See, I can't even write properly. That's an E. Elasticity. Oh no, sorry, what's wrong?
The focus.
Is it?
Okay, now?
Yeah,
We say elasticity, but it's simply a fancy word for
now we can actually answer this.
sensitivity or responsiveness. We can call it elasticity, we can call it sensitivity, we can call it responsiveness. If you've got curly questions in the exam, the best way is to swap it in your head and call it responsiveness instead, or call it sensitivity instead, yeah? Now, elasticity is a general term. There's different types of elasticity. The one that we tend to spend most of our time on is, which type of elasticity? Price elasticity of demand. So if I say price elasticity of demand, I am referring to how responsive, who? Consumers or producers? How responsive consumers are to a change in price. I'm referring to how responsive consumers are to a change in price. Now, to judge whether something is responsive or not, I can't just use numbers. I can't just say Macquarie enrollments have increased by 1,000 students. Because is 1,000 a lot or is 1,000 a little? You can't say it, right? It's just a number by itself. That's where percentage change comes in. So to judge whether something is sensitive or not, to judge sensitivity, we need percentage changes. Because a number by itself doesn't tell you whether something is responsive or not. 1,000 students at Macquarie, if Macquarie only had 2,000 students to begin with, that's a huge percentage. But if Macquarie has 100,000 students, 1,000 is only 1%. So that's where elasticity in terms of percentage change comes in. So to judge whether something is responsive, sensitive, elastic, we basically compare the percentage change in quantity to the percentage change in price. In trying to decide whether something is sensitive or not, we compare the percentage change in quantity to the percentage change in price. So, forget about these axes. I've actually wrote it on paper. So this is just random paper with axes. So there's two possibilities. The percentage change in quantity could be bigger than the percentage change in price. The percentage change in quantity could be smaller than the percentage change in price. So this is like saying the Boost juice across in the other building, they've reduced prices by 5% and the quantity has increased by 20%. Would you say consumers are being responsive? If the price changes by 5% and the quantity changes by 20%, that's quite responsive, right? There's only a small change in price percentage-wise, but a big change in quantity percentage-wise. So therefore, we say that this is elastic. Elastic is simply a word for sensitive. Consumers are responsive to a change in price, are very responsive to a change in price. On the other hand, Boost Juice could have reduced prices by 5%. However, their sales increased by only 1%. Is demand quite sensitive? No. 5% change in price, but only a 1% change in quantity. So demand is, we say, inelastic, not very sensitive. Demand is not very sensitive in this case. Is that okay? So that's where now a formula comes in to judge the value for elasticity. So we need the percentage changes to judge whether something is sensitive or not. Comparing the percentage changes tells us whether something is elastic or something is inelastic. Now we introduce the formula and we say, how do we calculate price elasticity? It is the percentage change in quantity divided by the percentage change in price. In other words, you can make a note, it's a ratio of percentage changes. Okay, so let's go back to the two possibilities. If the numerator is greater than the denominator, this answer would have to be what? More than 1. So when something is elastic, we say price elasticity is bigger than 1. If the numerator is smaller than the denominator, then the price elasticity will be less than 1. What's the third possibility? The percentage change in quantity and the percentage change in price are equal. Therefore, the price elasticity will equal 1. In this case, the term we use is unit elastic. Now, technically price elasticity is always negative, so technically we always talk in terms of absolute value. We ignore the minus sign for price elasticity. The minus sign doesn't give us any more information, which is why we ignore it. For price elasticity, probably make a note for your study that the minus sign or plus sign does matter for income elasticity, it does matter for cross elasticity, but it does not matter for price elasticity. Because when the price goes up, the quantity has to go down. When the price goes down, the quantity demanded has to go up. So the minus sign doesn't give you any extra information, so it's just convention to ignore it. Okay, you've seen this example in a cheat that we didn't actually do live in class, so let's use that. This is when you were giving your assignment submissions and we didn't actually do the solution in class. Okay, so the price of bread has gone from 95 cents to $1.05. the quantity demanded of bread has decreased from 5.001 million to 4.999 million. Let's calculate price elasticity. So, price elasticity is percentage change in quantity divided by percentage change in price. How do you calculate a percentage change? You look at the difference, the change, and divide by the first, divide by the original. Percentage change in price, likewise, you look at the change and divide by the original. What is the change in price? $0.10? So I'll just write it here itself. The change in price is 10 cents. What is the original price? Since it says before, after, the original price is 95 cents. What is the change in quantity? 2,000. What is the original quantity? 5.001 million. So now we can plug that in our calculator. $2,000 divided by 5.001 million divided by 10 cents divided by 0.95 gives us approximately 0.0038. Notice I don't worry about the minus sign. I ignore the minus sign altogether. Also, we don't report dollars or percentage or grams or kilos. Make a note that elasticity is units free. It's simply a number. It's simply a ratio. Elasticity is just a number. It's just a ratio. Now, I'm going to reverse this. Let's swap it. Let's say this is before and this is after. I'll give you 2 minutes. Can you work out what the price elasticity is after swapping the direction? So same example, but the direction has been swapped. Have a go, please. The change in quantity is still the same, right? 2,000. But now the original quantity is, since we're starting here, this is the before, now the original quantity is 499,000. Change in price is still 10 cents, but the original price is now $1.05. What's the answer, please? 0.0042 approximately. Is it the same as before? Is it around the same ballpark figure? So, do we get the same answer for a price increase and a price decrease? Obviously not. So, we don't get the same answer for a price increase and a price decrease. Why? Because while the numbers are the same, while the changes are the same, the percentage changes are not. So we don't get the same answer for a price increase and a price decrease. Because while the numbers and the changes are the same, the percentage changes are not. Which is where what formula comes in. This is where the midpoint formula comes in. What we do, essentially price elasticity is the same concept, which is it's still percentage change in quantity over percentage change in price. However, instead of dividing by the original quantity, now we divide by the average quantity. Instead of dividing by the original price, we divide by the average price. Can you try that, please? Same numbers, but using averages as the base instead. So the changes are the same. So you'll need to work out the average quantity and the average price first. The average quantity is 5 million, and the average price is exactly $1. You'll get elasticity is exactly 0.004. What's the advantage of the midpoint formula? It gives you the same answer regardless of whether the price goes up or down. It gives you the same answer regardless of which direction you're going. We will tell you which one to use. To be honest, the only reason we're showing you midpoint is because the textbook does it, and every first year textbook under the sun does it. It's actually better to use point because it's more accurate, because you're actually calculating a proper percentage change. So from a day-to-day life point of view, you'd use point. The textbooks tend to use midpoint to save confusing students why the answer is different all the time and thinking whether I should do this minus this or that minus that. This way you'll get the same answer, looking at the average. So we'll tell you which in an exam situation. But you're not just here for exams, you're here to learn about life. Aren't you here to better your life? Yes. Yeah. So next time you're at somewhere and you apply elasticity, you'll be like, oh yeah, I know that elasticity thing.
I had a discussion with someone about excise tax the other day.
See? And did you invite them to come to Macquarie University and learn more? Missed opportunity. So where does this fit in with the market structures? How many market structures are there? On this extreme we have. Oh, I brainwashed you. That's pretty arbitrary that I could very well put perfect competition here. But because I brainwashed you, perfect competition must be here. Get what I mean? It could, Monopoly could be here.
Same with the colors.
When you start saying demand, then you're completely brainwashed.
Amsterdam can we say anyway.
Ah, see? They've got the correct English. Perfect competition, monopoly. Okay, you all know this, but very quickly, how many firms in perfect competition? Ooh, very many. Very many firms. Why? There are no barriers to entry, no barriers to exit. Monopoly. Just one firm. Why? Because there are high barriers or barriers to entry. In perfect competition, the products are exactly the same, identical, standardized, homogeneous. Either word you could pick. In a monopoly, the product is unique. Okay, so where does elasticity come in? Elasticity means sensitivity, means responsiveness. So, if I'm in a perfectly competitive market, if all of us were firms in perfect competition, and one of us decided to increase the price, that one of us, that firm would sell nothing. The quantity would go all the way to 0. We say in perfect competition, the demand curve is perfectly what? Perfectly sensitive. Now we can say perfectly elastic. So in perfect competition, the demand curve is perfectly elastic. We say elasticity equals infinity. This is for a single firm, yeah? Not for the market. The demand curve for a single firm is perfectly elastic. Of course, finding a pure example of perfect competition is very rare, which is why we put the two extremes, and then in the spectrum of market structures, we have two others in between, one of which is monopolistic competition, so named because it has some features of perfect competition and it has some features of a monopoly. There are many firms, but not as many as perfect competition. So I've chosen the terminology many firms as opposed to very many firms. There are still no barriers to entry. You'll need some sort of license or ABN to get in, but there's no law that says you can't. So we still say no barriers. So you can't just sell food, you'll have to get a license to serve food. But that's not a barrier because there's no law that says they won't give you a license. Whereas in a monopoly, Star City, the Star exclusive license, so that's a barrier because you can't get another one. But the products are differentiated, which is the unique feature of monopolistic competition. The products are not exactly the same. They are slightly different, at least by the brand name. So, if I was to raise the price, would I lose every single customer? No. Would I lose some customers? But would I lose some? Yes. So, would you say that the demand curve is more or less elastic compared to perfect competition? Is it more sensitive to the price or less sensitive to the price? It will be less sensitive to the price because the products are somewhat differentiated now, right? So now you're moving to a market structure like stationery. We all have slightly different stationery. So these firms have some degree of market power. And you can probably make a note that the steepness of the demand curve reflects the degree of market power. So demand is less elastic than perfect competition. So if I were to increase the price, I would lose some, but not all. See, in perfect competition, it goes all the way to 0. In monopolistic competition, it does not. The steepness of the demand curve reflects the degree of market power. Also, you could add it reflects the degree of product differentiation. Now, a monopoly is extreme product differentiation. It's so extreme that the firm has got a patent for its product, and now it is illegal for any other firm to copy this product. Now we have a barrier to entry. I'm putting the pink dot in to show you that the pink dot is the same point in each of the 3 graphs, because you've got to make sure it's ceteris paribus. So the pink dot is the same point in all 3 graphs. Would demand in a monopoly be more or less elastic than monopolistic competition? This is now even more product differentiation. So the product would be even less elastic. We are now moving to a steeper demand curve. If I raise the price, will I lose some customers? Yes. But compared to monopolistic competition, I would lose less customers. So we say the demand curve is less elastic than monopolistic competition. Be careful that you write the word less elastic. Don't write inelastic. We're not saying demand is inelastic, we're just saying it is less elastic. There's a difference, right? Inelastic means the answer is smaller than 1. Less elastic means, have a look here please. Less elastic means here elasticity is infinity, here elasticity could be 10, here elasticity could be 3. All of those numbers are elastic. So I'm saying it's less elastic. I'm not saying it is inelastic. So the degree of market power is reflected in the steepness of the demand curve. How different your product is reflected in the steepness of the demand curve. If you have extreme product differentiation, you get a patent, then you become a monopoly via a legal barrier to entry. But that's not the only way to be a monopoly. You can have a monopoly through a legal barrier. You could have a monopoly through control of resources. You could have a monopoly through economies of scale. I just poke the other market structure in, which is oligopoly, which we're just doing this week. While it fits in the spectrum, as you'll see in this week's lectures, the model is a completely different model, which is game theory. So for this, we don't use any graphs or anything like that. We use game theory because of the fact that firms in an oligopoly are interdependent. Because we have a few firms. Why there are a few firms? Due to barriers. And the main feature of oligopolies is that their firms are interdependent. So it doesn't really fit in from this model's point of view. It has its own model. So just to analyze oligopoly, we have a different model altogether to take into account of interdependence. Sounds good? So back to elasticity. We've got different steepnesses of curves. So why does a firm need to worry about elasticity unless it's perfect competition? This is the graph where we draw one on top of the other. You all should be familiar with that by now. So it's got to be vertical. For any linear demand curve, so this is for any market structure but perfect competition, right? For any linear demand curve, what do we know about the top half? The top half is elastic. I won't go through the proof because of time. You are not required to know the proof anyway. But you do need to know that the top half is elastic. There is a mathematical way of proving it. And the bottom half is inelastic. The middle has an elasticity of 1. which reminds me, you do need to know the equation, how elasticity is connected to the slope. Elasticity is 1 divided by the slope times original P over original Q.
How do you work out the slope again?
Slope is delta P over delta Q. Now, you won't be required to calculate the slope. What I mean is you need to know how to use that formula. But slope is simple, right? Change in P over change in Q. Okay, so top half is elastic, bottom half is inelastic, the middle has an elasticity of 1. What am I going to draw underneath? Total revenue. What do we know about total revenue? The biggest total revenue is in the middle of the demand curve. The biggest total revenue is in the middle of the demand curve where elasticity equals 1. You can call it total revenue. You can also call it total expenditure. Revenue is from the firm's point of view. Expenditure is from the consumer's point of view. So, we'll pick a random point on the elastic side, any point on the elastic side. So the aim is to see why is elasticity useful for a firm to know. Let's say we are aware that the demand for our product is price elastic. So now I've picked the elastic side. And what if we raise the price? What will happen to our total revenue? Our total revenue would go down. If we pick a point on the inelastic side, and we did the same thing. So our firm, the product we sell, we are aware that it is price inelastic. Now we know, through knowledge of elasticity, that raising the price, if the product was price inelastic, would cause total revenue to go up. So we get different answers depending on the value of elasticity. If you raise the price and demand is elastic, your revenue will increase. your revenue will decrease. And if you raise the price and the product is priced inelastic, your revenue will actually increase. And there's actually an intuition behind it. How do you calculate total revenue? Price times quantity. The thing is, we know from the law of demand that raising the price will cause quantity demanded to go down. The arrows are going in opposite directions, so total revenue could increase, decrease, or stay the same. So based on the law of demand alone, you wouldn't be able to pick what happens to total revenue. But if we're on the elastic side, elastic means responsive. Small change in price will cause a large change in quantity. And the change in quantity is so much that overall total revenue will go down. Because that's what elastic means. This is if demand is elastic. A small change in price causes such a large change in quantity, so much so that my total revenue has actually decreased. On the inelastic side, same equation, total revenue is price times quantity. If I raise the price, the quantity will decrease, but inelastic means even if I have a very big change in price, I will only have a very small change in quantity percentage-wise. That's what inelastic means, yes? Big percentage change in price, small percentage change in quantity, so much so that my total revenue actually goes up. This is when demand is inelastic. The third possibility is if you are near the middle. If you are near the middle and you cross to the other side, also near the middle, your total revenue would remain. If you're near the middle and you cross to the other side of the middle, your total revenue would be constant. So we can conclude that if elasticity equals 1, total revenue remains unchanged. If elasticity equals 1, total revenue remains unchanged.
What do you like this to
All the questions in the exam are pretty direct. They're not like the assignment. So it's you might have to use the model to answer the question, correct?
Yeah.
But it wouldn't give you a curly application, no. That was done in the assignment. So you have to know why a firm needs to know about elasticity and how the different changes in price on the different sides of the demand curve or the different types of elasticity give you a different value for total revenue.
Total revenue as well, isn't that where the marginal revenue equals 0?
At the very top, yes. We can show that because it doesn't really add any value, but yes, you can show that because when you had the demand curve.
So is that like a pointless fact,
Sorry?
Is that a pointless fact,
It's pretty. So in the middle of the demand curve, elasticity is 1, right? And how many times steeper is MR? MR is twice as steep. MR is twice as steep as demand. So by virtue of drawing MR twice as steep as demand, in the middle, MR equals 0. So it's interesting, but do you want to see something more interesting? I was saving it for next week, but now you won't be surprised anymore. So, we know the middle elasticity is 1. You'll have to act surprised next week. We know the MR curve must be 0 here, because MR is how many times steeper? Twice as steep. Now, if you poke the marginal cost curve in, this is going to amaze you. You actually might not sleep tonight. That's Q star. That's P star. What do you notice about that point? That's what consumers are willing and able to buy, willing and able to pay. But that point is on the what side? It will never be on the inelastic side. It will never go further past the middle. Isn't that amazing? Yeah? So saving that to the end. All the surprises are in the last lecture. So you can make a note, just mathematically speaking, because CMC can never be negative. You can never have negative marginal cost. So just by the maths, this is why maths is amazing, so you can make a note that a profit maximizing monopoly or firm in monopolistic competition will always produce on the elastic side. A profit maximizing monopoly or firm in monopolistic competition will always produce on the elastic side. They will never actually profit maximize on the inelastic side, which I think is an amazing fact. Yeah? A profit maximizing firm will always produce on the elastic side. Which is why I kept mentioning before, when I showed you this graph, never use the word inelastic, just say, remember I said don't say inelastic, I said to say less elastic. Because actually, the answer is always elastic if they are profit maximizing. You'll always be on the left, never on the right, if you're profit maximizing. So next time someone tells you, monopolies products, hey, they're inelastic, and then you go, no, if they're profit maximizing, actually, it'll be on the elastic side. It'll be less elastic, but it will still be elastic. I have never seen that highlighter color before.
Do you like it?
We might swap next week. But then again, you've already...
You get them all over the place.
Sorry?
I haven't seen it.
I've used it, and you only use non-used highlighters.
Yes, I know. That's why I said it's no point now. Coral. No, we only buy those 6 colors that you see. Someone gave me 12 colors last week. A student. Yeah.
Is that why you got them?
No. It was Smiggle set. I put it on Instagram. Yes.
Your phone is your laptop?
Yes. When you get married, you have no one to call. So that's your phone.